Your 120, page 120 workbook. So this activity is to study the scattering of light. So this apparatus include the dilute milk or milk powder and water, which is combination, a mixture of milk powder and water. Okay, stop your raise hand button. So I already lowered down your hand. Thank you for your response. So let me discuss this activity, page 120. Yeah? So a light source, which is a slide projector, this one. Or we can use the torchlight. The slide, a light source, which is a slide projector, is better than torchlight. The white screen here, and then beaker, this one, and color pencil. Color pencil. To set up the apparatus as shown in the diagram, like this, we put the screen on the right of the beaker, and then we use the slide projector to give the perfect white light. Fill the beaker with dilute milk, which is a mixture of milk powder and water. Number 3, direct a beam of light from the slide projector so that it passes through the dilute milk. And then number 4, observe the color form in the dilute milk in the beaker and on the screen. Color your observation in above diagram. So the color pencil used to color the to make it clear that image appear on the white screen here. So what is your guess? What is your answer for the observation in the dilute milk here? What is your observation? What we can get? What is the color? What is the color in the dilute milk? We have a blue color here. So what happened to this blue color? Well, we can see that in the milk here. We can see any idea? We can see the bluish color. BLUIISH, which is the blue color one. Okay, and then on the screen, what color appear on the screen? Can you guess what color appear on the screen? The red or the blue? Blue already scatter in the medium of dilute milk and water. So what is the other longer wavelength light? Okay, so the blue one with the shorter wavelength will scatter in the medium of dilute milk. Meanwhile, the longer wavelength, which is red, can approach the screen here. So in this diagram, sudah tunjuk here the red spot. So we can see the red spot on the white screen. Red spot. Sudah ada dalam gambar jawapan. Red spot. Sebab red ini panjang wavelength, jadi dia dapat travel far, and then it can reach white screen. Yeah. Blue tak dapat pergi jauh sebab dia shorter wavelength, so dia akan stay here, scatter in this beaker. What analogy can be drawn on the materials and apparatus in this activity with nature? So the slide projector represent what's class in our nature, which is the sources of light. What is our sources of light? Here the sun, bagus. So we have the slide projector represent the sun. Okay, and then the dilute milk represent what class? Check about. Okay, the sky. Thank you. The sky. We have the sky. Okay, number 2. What analogy can be drawn on observations in this activity and the natural phenomena? The color that appears in the dilute milk, which is the bluish, now represent what phenomenon? We refer to the blue one, bluish. The blueness of represent the blueness of the sky. Or what we can say that the sky looks blue during day. And then the spot of light on the screen represent what? The sunset or the sunrise phenomenon, or the redness of the setting sun represent the redness. The setting sun. Okay, so we have two phenomena here related to the scattering of light. The sky looks blue, and then the second one is we have a reddish during sunrise or sunset. Okay, finish page 120. Now I'm going to share page 121. Question number 3. Name the process that take place on the white light in this activity. The white light here. The process that take place on the white light. So what process class? We have a few process before of light, reflection, and then dispersion, and then scattering. So which one is the answer? Which one? Scattering of light, right? Okay, good. Thank you. So scattering of light. Number 3 here is scattering of light. Take, okay, number 4. Number 4. State the color of light that is more scattered. So which one? And less scattered. You know that less scattered means we have the longer wavelength in this activity, and give reason. Okay, so which one is more scattered? The blue or red one? Blue or red? More scattered. Check box. Okay, the blue one is scattered more compared to the red one. Okay, good. So your answer here, blue light. Blue light is more scattered because this light has a shorter wavelength. Short wavelength. Short wavelength. Kalau ada comparison baru kita letak shorter. So the second answer will be red. Red light is less scattered because this light has a long wavelength. Okay, question number 4. Number 5. From your answer in question 4, give reasons in your observation of dilute milk in the beaker and the spot of light on the screen. So okay, we have to select the answer from this box. So which one is the suitable one? Let me zoom out to get the full. Okay, we have the first answer here, long, bluish, red, short, and blue. So choose the best answer for the first statement. Here is the reason of the observation. Okay, which light is scattered the most? Check box. Okay, the blue one. Thank you. So the blue light is scattered the most. So blue here, BL. By the suspended particle, because suspended particle is located in this beaker, suspended particle, because it has a short wavelength. Therefore, the dilute milk appear bluish. Okay. And then the second one here is scattered the least. So the red light is scattered the least because it has a long wavelength. Therefore, red light pass through the dilute milk and produce a red spot on the screen. Red spot. Give 3 examples of particles in the air that can cause the scattering of light. Okay, what particle class? We discussed already last Friday. Last Thursday. Dust particle, 1. Another 2 particle. Okay, the first one is dust particle. Lagi. Ada 3 di sini. The first one is dust. Second, checkbox. Snow particle is not correct. It's not clear one because snow particle we refer to the certain places only. So the best answer will be water droplets. Okay, and then the third one. Okay, I always refer to your checkbox. We have what's the third one, which is oxygen, hydrogen. What we call that? Gas molecules. We call it gas molecule. Okay, and then conclusion, the of light cause the blueness of the sky and the redness of the setting sun. The scattering of light, not the dispersion, the scattering of light. C-A-T, double T, yeah? Scattering. Scattering of light. Okay, finish. Let me continue. Page 122. 122. Okay, write down the date. Today is 3rd of August 2021. Page 122. A student observed the color change of the sky at different times. The student accessed the internet and got information that the wavelength of light affected the phenomenon. Explain the student's observation about the blueness of sky and the redness of the setting sun, or the redness of the sky. So we have an answer here: short, blue, red, least, most, thick, long, and thin. We choose the best answer based on the first situation here is the first phenomenon, which is the blueness of the sky. The sky looks blue. The blue light is scattered at this point. So at noon, sunlight travel through a checkbox, a thin atmospheric layer. Okay, good. Hopefully you dapat follow. Saya dah slowly ni writing. So what light with a wavelength is scattered the, you refer to the diagram here, we have the blue light. So blue light. Yeah. Blue light with a, okay, long or short. So we can choose from here. You know that the blue with the short always with the short wavelength. Is scattered the least or most checkbox. By the particle in the air, such as dust particle, gas molecules, and water vapor. So least or most class. And we see here we have a lot of arrow here, which is, and then our eyes referring to this part only. And then the red light with the longer wavelength still moving to the other place. So you can see a blue light mostly here when the particle scattered the most at this point. So the blue light with a short wavelength is scattered the most here. By the particle in the air, okay, in all direction. The sky appear bluish blue. Okay. The redness of the setting sun. Okay, at when the sun at the horizon, then we stay at the which is opposite to the sun, so we can get the red light the most compared to the blue one. So during sunset, sunlight travels through a a, a thick atmospheric layer. And then we have the red light, which is the red light approach at our eyes, red light with a long wavelength is scattered the least. And travel through the atmospheric layer. The sun or the sky appear red. Okay. The most scatter happen at this place, the blue one, during the day on the other countries. This is Malaysia, and then this one, let's say this is when Malaysia getting sunset. We have Africa here still noon, ataupun masih lagi tengah hari. Okay, this is the scattering, the solving problem related to the scattering of light. So we have two phenomena that are related to the scattering of light. The first one is the sky looks blue, and then the sunset, or what we call that, the sunrise, sunset look reddish or red. Okay, so let me stop the presenting. Then we proceed with the addition. So I'm gonna share the YouTube video. So please study this video before we answering the exercise from the workbook. Please pay attention. Where is my... Stop.